All right, today we're going to start talking about the volume of prisms. We're going to get into the volume of all kinds of three-dimensional shapes, but today we're going to stick to the prisms. Remember, the prisms are the shape that have a common base, top, and bottom. We've done surface area, which is essentially painting the outside of an object. Today we're going to talk about the volume, which is filling in the inside of the object. This is a three-dimensional measurement, so as we finish these, we should always have measurements cubed. So let's take a look at a few examples. So this example says, what is the volume in cubic inches of a rectangular prism with a height of 16 inches, a width of 4, and a length of 20? So it would look a little something like this. We have a 4 inches in width, we have 20 inches in length, and we're about 16 inches in height. Well, our volume formula for a prism, a volume formula for anything, is the base area times the height. Now, since this is a rectangular, all we have to do is length times width times height. So in this case, we would have 4 times 20 times 16. So the area of this object would be 1280, and we are measuring in inches, so this is going to be square inches. And remember, that has nothing to do with a number. That is just the measurement of the value of the measurement we're measuring in. We don't square the number 1280. It's just letting us know, oh, that's actually wrong, because this is volume, so this is inches cubed. Inches cubed. And we did multiply 3 numbers, so power 1, power 2, power 3. So we have 1280 inches cubed. That's also known as 1280 cubic inches. So here we're given a pentagonal prism, and we actually are given the base area. Anytime we're trying to find the volume of a prism, it is really base area times the height of the object. It's very important that we recognize the height of the object, because a lot of times we're going to run into base of the object as opposed, or base times height. Remember, this is the height of the object. Now, they were kind to us, and they gave us our base area. So our base area is 38 square inches. So that would be this face that we're looking at right here. So since it is 7.4 inches tall, we essentially have 7.4 of the highlighted unit that I have right there. So all we need to do is multiply base area times our height. So we're given our base area times our height of 7.4. So the volume is going to be 281.2. We are measuring, and it says units here, so this will be units cubed. So 281.2 cubic units. So this example, we're given another pentagonal prism, and in this case, the volume is still the same. It's the base area times the height. By the way, this is essentially the generic formula for any type of shape we're going to deal with. In this case, we are given the volume 237.6, and we're given the base area of 36. And we're asked to find the height of the prism. So in order to solve for h here, we need to divide both sides by 36, because it's 36h. So once I divide both sides by 36, I learn the height of my prism is 6.6. And we are measuring in an undefined unit, so it would just be 6.6 units. If it were inches, meters, whatever the case may be. Our next example says find the volume of the cylinder in cubic centimeters that has a height of 8 centimeters and a base with a diameter of 16 centimeters. Round your answer to the nearest tens place. So here's a rough draft of our little cylinder here. It has a diameter of 16 and it has a height of 8. Obviously my picture is not drawn to great scale here because that's not matching, but that's not the point here. So what we need to do, again, volume essentially is base area times height. You will have a different formula and you're welcome to use this, but I prefer just to find what is the base area. Well, our base shape is a circle. So the area of a circle is radius squared times pi. Since our diameter is 16, our radius would be half of that, 8. So our base area is equal to 64 pi. So this base area that we have, I'm highlighting here, is 64 pi. And essentially, if you think of it this way, we have just stacked up 8 of those. So we are going to take the base area times our height of 8. So I'm going to leave it in terms of pi as long as I can. So my volume here is going to be 512 pi. 512 is 64 times 8. And then I am asked to put this to the nearest tens place. So when I multiply this times pi, I get 1608. And it's 0.495, so that would round us up in tens place to 0.5. We are measuring in centimeters, so this would be centimeters cubed. So in this example, or cylinder, we're given the radius and we're given the height of 20. So we have a radius of 4 and we have a height of 20. Last one was actually a little tougher because we actually had to do some work as far as turning the diameter into a radius, but remember it's base area times height. So if I'm looking for my base area, my base shape is a circle, which is radius squared times pi. Since my radius is 4, my base area is 16 pi. You could turn that into a decimal, but the sooner you turn it into a decimal is the second that you establish rounding, and whenever you have rounding, you've created margin for error here. Now, this is 20 inches tall, so it's essentially like I have 20 of these base circles. So I'm going to multiply 16 times 20. So my volume is going to be 320 pi. And I'm going to multiply that because it did ask me to write this in the nearest tens. So my volume is 1,005.3109 or 3.09. That is not enough to round us up, so it's going to be 0.3 inches cubed. So in this example, we're asked to find the volume of a hemisphere. That would be half of a sphere. Now the volume of a sphere is 4/3 times the radius cubed times pi. So we can find the amount that this sphere is and then cut it in half, or we could do the 1/2 right here at the beginning. Let's go ahead and establish what we have. If we had the whole sphere, it's 4/3 times the radius cubed times pi. Well, we know that the diameter is 30.3. So if the diameter is 30.3, the radius is half of that. So my radius would be 15.15. So I'm going to cube that number. And what I end up with is 3 477.27 times 4/3 pi. So I'm going to take that amount and I'm going to multiply it times 4/3. Remember, you can use the alpha F1 and multiply times 4/3, and I get 4,663.4 pi, and we are dealing with feet cubed. Now, this was an entire sphere, but we were looking for a hemisphere. So we're going to take half of that amount. Leave the pi out of it, as I always say, leave the pi out as long as we can. So this is the full sphere. So our hemisphere is going to be half that amount. And again, leave pi out of it as long as you possibly can. So I'm going to take half of this number, which is 2,318.2. So this is my volume of the sphere. If we were writing it in terms of pi, but we are writing it to the nearest tenths place, so we're going to multiply that times pi, and what we end up with is 7,282, and then we get 0.76. That's enough to round it up to, so it'd be 72.82, and we are measuring in feet cubed. And that circular shape does hold a lot of volume. Holds a lot of volume in those. So that would be our answer to our last example.